Hello, welcome to part 2 of the Edexcel Biology Paper, Paper 1. So this is where we got to last time. So a slight recap where we got to last time. Let's continue. Okay, figure 4 shows the interpretation of BMI values. Okay, so there's a table to show how they will be interpreted by doctors, medical staff. Males with a waist to hip ratio above 0.9 are defined as abdominally obese. Okay, so in the abdomen area, so stomach region. Explain what the BMI and waist to hip ratio for male A shows about his waist, so his weight distribution. There's a few key words there. Weight, waist, lots of words that's in the male A then. Male A, BMI 27.3, waist to hip ratio 0.85. So let's just write that down. So this is BMI 27.3. Okay. BMI 27.3, and then waist to hip. Okay, that is 0.85. Okay, so what does that say? So 27. So he's overweight. So male A is overweight. Okay. By the BMI. Okay, so that's just BMI. So different measurements. BMI, remember, was just the height and the weight. Whereas waist to hip ratio, okay, 0.85. So by his waist to hip ratio, okay, he's not abdominally obese. Okay, so his waist to hip ratio shows he's not abdominally obese. Okay, abdominally, it's up there. I can't remember to spell it. The word is up here. So that means that's a little bit of extra here. So the weight distribution. So the weight distribution is not around his vital organs. So around the abdomen, you've got the vital organs. Okay, so the weight distribution is not around his vital organs. So actually, that's another thing I look for. I do that because the worst place to have fat, okay, you may get questions about this, is around the vital organs, like obviously in your abdomen, so your body. So it's actually healthier to store fat when you can't around the lot of legs, hip area, things like that. So that's why I talk about males here, because sometimes because females have wider hips and things, it's not actually as always as bad to store the fat around there. That's why different measurements, BMI, abdominal, there's other ways of measuring it too. See where the fat is stored, because some fat is not bad, and as I've said before, that you always need a little bit of fat stored for your body to actually work correctly. So it's no use having no fat, because that's not great. Okay, but to store fat around the vital organs, I mean, you don't choose it, it's just what your body does, but it's not a healthy thing. So people obviously might be advised them to lose weight if their body stores their fat around their vital organs. Okay, so let's go on to the next question. Okay. Figure 3A shows 2 potato chips. So they say chips, they mean obviously they've cut a potato into that size. Okay, so not necessarily, well, they are like chips that you buy, it's in a bag, but when a chip just means a part of something, that's why we call them chips. Okay, chip A and chip B. Figure 6 shows some information about each potato chip. Okay, we've got quite a lot of information here about each one. Potato chip A, length could call it width, couldn't you? Because length, width, height, or length, y, x, y, z. Total surface area. Okay, this is going to be an important thing because I've not seen lots of questions these before. Total surface area, 4 sides in centimeters squared. 18. Total surface area, top and bottom, 4.5. Total surface area of chip. Okay, so that's the sides. Yeah, this is a careful one to look at. Sides, that's the top and bottom. That surface and the bottom surface we can't see, and that's the total one. Okay, so this is a bit of maths really at the moment. It says calculate the total surface area of potato chip B, so the bigger one, using the formula 2xy plus 2y. I mean, you could do it the normal way in maths, couldn't you? I mean, I teach maths a lot. It's just the surface area of all it is the surface area of a cuboid. Okay, so if you don't understand that formula, you can work out normally, but also x, y. So let's just do that then. Okay, so the formula they've used using the numbers. So 2 times xy, 5 times 2, okay, plus 2 times 5 times 2. Okay, so that's the sides. X, yeah, the sides. Okay, plus, and we're doing the top and bottom now. But yeah, if you know how to do this, you can just do it straight off. If you know a form of a cuboid, which probably everyone does. If someone labelled those up, they would say, example, I'll finish this, sorry, and then I'll go back. Okay, that's 2 times, that's top and bottom. Okay, so it's 48 we get there. Let's write that in there. So, okay, so you could have done it 5 y2 z2. That's where that's come from. Okay, so if you know how to do the volume of the surface area, you might ask volume in a minute. Surface area of a cuboid anyway. Remember, centimeters squared. Okay, is the volume. So think about putting a grid over it. That's volume. So that's 22.5. And that's 48. I wonder what they're going to ask us next. I think I can assume it's going to be about surface area. The potato chips are placed in distilled water. So distilled water hasn't got anything dissolved in it. It's pure water for 20 minutes. Figure 7 shows the increase in mass of each potato chip. A, increase in mass, 0.1 grams. B, 0.3. Explain why potato chip B has a greater increase in mass than potato chip A. Yeah, this is about the surface area. That's why I'm asked to work that out. Always think about why you may have been asked to work something out. So chip B has a greater surface area than A. So more water is absorbed into chip B. You might have done some class with potato you cut up. It sort of kind of reminds me of when you cook potatoes, you have to make sure they're all the same size. Okay, when you boil them or if you roast them, otherwise they don't roast at the same rate and things like that. Okay, I was explaining that to my little cousin the other day about cutting potatoes up in the same size. And I was also roasting a pumpkin as well and cutting up in the same size. So yeah, scientifically you can explain why you would do that, because otherwise you'd get more water being absorbed into one and then they wouldn't cook very well in the oven. You have to make sure they're all the same size. Okay, potato chip A is transferred from the distilled water into a concentrated salt solution. Explain what will happen to the cells in potato chip A. Okay, so if it's concentrated salt solution, there'll be a greater salt solution gradient outside of the potato chip. So what actually happens is that it's osmosis. This is what you might have done in class. So osmosis. So remember, osmosis is the movement of water. Okay, it's water exclusively of water from a high concentration of water molecules to a lower concentration of water molecule. I keep saying that because it's exclusively for water. Because diffusion can be for different things, but this is for water. Diffusion is for things in the water, when osmosis is the water, okay? A high concentration of water molecules to a lower concentration. So then we've got to, we know what osmosis is at lower concentration. Then we just say what's going to happen. Okay, so what happens here is that water will move out of the cells. Okay, and into the salt solution. Okay, so I explained it. Okay, and why as well there. I'll go back up just to let you screenshot that. Okay, so B. The potatoes of a potato plant develop underground. So if you've grown potatoes, you know this, so you have to dig them up. Okay, we've got some last year. So explain one difference in the subcellular structures in a cell. So we're talking about cells, so small scale, in the potato and those in a cell in the leaf of the potato plant. Okay, so in the potato itself, remember it's a tuber. Okay, its Latin name for potato is Solanum tuberosum because they're tubers potatoes, they grow underground, and those in the cell. Okay, so this is actually a lot easier than we think. People, if this was said in a different way, I think people would forget this very, very quickly. Okay, so it might not be obvious straight, but what he's just trying to say is what the difference is about the jobs in the potato, of the cells in the potato, than the leaf. So you go, well, leaf has to photosynthesize, everyone will say. Okay, so that's exactly what the answer is. Okay, there are no chloroplasts. Okay, there are no chloroplasts. So you get the same thing with the roots, isn't it, as well? No, because they're underground too. No chloroplasts in the potato cells. And there are no chloroplasts because they are underground and do not photosynthesize. So honestly, it's easy as that. Okay, sometimes it's the way the question is worded that confuses people, because they do know the answer to this. They say, well, they don't photosynthesize straight away. I've taught lots of classes in science, and everyone would know the answer. Yeah, it's the same if you got asked about a root hair cell, okay, or a root cell, or anything underground. It's because it doesn't need to photosynthesize. Leaf would do that. Okay, next one. Yeah, so in biology, you can get lots of human biology mixed in plants. So make sure you know what you're talking about. I've seen people accidentally write about a plant when talking about a human and vice versa, because we both have cells. Okay, figure 8 shows a method of producing new plants. Step 1, cut a little bit off. So cells taken from parent plant. Okay, so it's not a cutting as such. I cut a little bit off. That's just some cells. Cells placed on agar growth medium. Cells develop into tiny plantlets, little plants. Plantlets grown in compost. Oh, you can do this. You want to take cuttings. You may, there's a rose in my garden, and I want to take cutting of it for when I move. I want to grow the rose in new garden. It's a very healthy, very fast-growing rose. And so if you get a plant that you like, you can actually take cuttings of it. You don't have to have agar. You can just take a cutting, like a leaf. We'll say why in a minute. Okay, why you can do that. And you can grow it somewhere else. So you can actually, lots of plants for agriculture. So things like apples, they're grown from cuttings what's called grafts sometimes. Maybe we'll get onto that because they, as an apple variety like a Golden Delicious, okay, will be a graft, it'll be a clone. Okay, so they're clones, okay, of the original plant. So some cells in each plant develop into root cells. Name the process occurring as these cells develop into root cells. So it's a process of where cells change to become specialized. And this process is called differentiation. Okay, so it's a bit like the same type of process of when you have an embryo, okay, human or animal, and differentiating things like the heart, the kidneys, things like that, okay. It's differentiated, same with plant, because the roots and the leaves are plant organs, okay. They have jobs that our organs do. Okay, so what I'm going to do there, I'm going to stop the video there, and I'm going to go and continue on in part 3. So thank you for listening. I'll see you in part 3.